Ever watched an AI agent just completely lose its mind after reading a single, massive error log? Yeah, if you've seen it, you know exactly what cognitive collapse looks like. Welcome to This Explainer. Today, we're diving into a real masterclass in systems architecture. We're looking at a huge shift in software engineering, the rapid move from you, the human, writing code line by line, to you supervising autonomous CLI agents like Google Antigravity or Claude Code. But here is the critical problem. If you don't structure their environment correctly, these agents will fail catastrophically, and they'll take your code base down right along with them. So, we're going to build a physical architectural blueprint today to definitively save your autonomous agents from this cognitive collapse. Here is our step-by-step schematic to structure your agent's workspace. 1. The finite context window. 2. Cognitive collapse and noise. 3. The context partitioning wall. 4. Foundation stones for persistent memory. 5. Sliding drawers for modular skills. And 6. Output filtering for clarity. All right, let's jump right into section 1, the finite context window. Okay, to truly master agentic workflows, I need you to completely stop thinking of data as this invisible, ephemeral text just floating around in the ether. Instead, start seeing data as physical space. It's physical geometry that you, the engineer, have to meticulously manage. So imagine your agent's context window as a literal, transparent container resting right there on your desk. This container represents a finite cognitive budget. As your agent begins a task, analyzing a codebase, planning a refactor, running terminal commands, clean, brilliantly colored reasoning tokens begin to fill up this transparent container. Every single token takes up actual space. And the reason this matters so much is that large language models have a strict ceiling on how much context they can hold while still keeping their analytical sharpness. When the container is filled only with high-value, highly structured reasoning tokens, the agent performs beautifully. It makes sharp decisions, it solves complex logic problems seamlessly. As an engineer supervising AI, your primary job is no longer just writing code. Your job is guarding this container and managing this physical space. Which brings us to section 2, cognitive collapse and noise. Here is where things take a really dark turn. What happens when we fail to govern that physical space? Well, the reality of software development is chaotic, right? And if you let that raw mess directly into your agent's brain, the results are literally destructive. Let's watch this context decay happen in real time. Step 1. The agent starts strong. The container is beautifully full of those clean, colorful reasoning tokens. But then, step 2 happens. The agent runs a standard command to update a package, and suddenly, unbounded build logs, like a 10,000-line successful NPM install trace, come crashing into the container like this heavy gray sludge. Now, for a human, a successful build log is just background noise. We just ignore it. But for an agent, reading a 10,000-line NPM install log is like a human being forced to read the entire English dictionary just to find a single typo. It consumes all their mental energy. Then we hit step 3. The agent, totally overwhelmed by the sludge, gets confused. It enters an unrecoverable recursive directory loop. Visceral, flashing red blocks of raw terminal errors completely clog the remaining space. Those clean tokens? Crushed. The agent immediately forgets your original instructions and just starts hallucinating wild solutions to problems that don't even exist. This is total cognitive collapse. But the good news? It's entirely preventable. To put that bloat into perspective, just look at this number, 191,300. This perfectly highlights the sheer volume of space you might be wasting before the agent even types a single command. In enterprise environments, developers often just dump all their available API tool schemas, AWS connections, Jira integrations, internal company APIs right into the agent's system prompt up front. But by using a technique called deferred tool loading, where tools are dynamically discovered instead of loaded all at once, you can save up to 191,000 tokens. That is a massive amount of physical space in our transparent container that you've just saved from instant, unnecessary bloat, leaving tons of room for actual problem solving. Okay, section 3, the context partitioning wall. So the chaos is real and the bloat is dangerous. How do we stop it? Well, this perfectly illustrates our first major defense mechanism, context partitioning. I want you to imagine physically dropping a heavy steel partition wall right down the middle of your workflow. On the left side of the wall, you've got the exploration phase. Let's say your agent needs to fix a bug in some legacy payment gateway from 2018. It needs to map the code base, open dozens of deeply nested files, research outdated dependencies. This phase is inherently messy. It generates tons of dead ends and useless historical tokens. But instead of letting that mess bleed over into the actual coding phase, you have the agent summarize its findings into a single concise markdown document. And then, boom, you drop the wall. You completely sever the history. You start a totally fresh context session for the action phase on the right side of the wall. The agent now executes code generation in a pristine, empty container, using only those summarized insights. We've completely stopped the historical token churn and given the agent a crystal clear mind to actually write the code. Moving on to Section 4, Foundation Stones for Persistent Memory. Now, you might be wondering, if we're constantly dropping partition walls and clearing the container to keep it clean, how does the agent actually remember our core non-negotiable project rules? We solve this with explicit memory externalization. Look, large language models suffer heavily from recency bias. As a session drags on, early instructions naturally just start fading away into the background. So picture heavy, unbreakable foundation stones anchored at the very root of your workspace directory. These are your declarative configuration files, like Gemini.md or agents.md. Instead of relying on the fragile conversational memory of an active session, you carve your strict architectural constraints, your forbidden packages, and your styling rules right into these stones. And because these files sit firmly at the root, your CLI harness will automatically inject them at the very head of every single new session. Your core instructions never, ever wash away in the noise of development. Next up, Section 5, Sliding Drawers for Modular Skills. Let's see how we build on this idea of keeping the workspace flawlessly organized. A massive anti-pattern in agentic engineering is just dumping every possible operational procedure into your root system prompt, crossing your fingers, and hoping the agent figures it out. Don't do that. Instead, think of a skill.md file not as a script, but as a modular storage solution. A sleek, sliding drawer. These are declarative workflow packs that grant your agent domain-specific expertise, like exactly how to audit a database migration or how to run a highly specific end-to-end testing suite. By keeping these complex procedures strictly in external skill.md files, they remain hidden and safely tucked away. They literally cannot pollute your base context window when they aren't actively being used. The kinetic action of this progressive disclosure is an absolute game changer for efficiency. Imagine step 1. Your agent is humming along writing front-end code, and suddenly it hits a niche database indexing problem. It needs specialized help. Step 2. Rather than forcing it to browse the open web or sift through a massively bloated system prompt, the specific skl.md drawer dedicated to database indexing seamlessly slides open dynamically. Step 3. The exact step-by-step schema, the necessary SQL tools, and the fallback protocols are extracted, used to solve the problem, and then the drawer quickly slides shut. By using these sliding drawers, your agent is never distracted by tools it doesn't need for the task at hand. It gets exactly what it needs right when it needs it, and your transparent container remains completely unburdened. And finally, Section 6, Output Filtering for Clarity. We've reached the final and honestly perhaps the most actionable step of our blueprint. We've partitioned the work, laid our foundation stones, and installed our sliding drawers. Now we have to actively govern the actual execution. Notice that single command there, pytest with the tb = flag. When an agent runs tests, the default traceback output for a single failing test can sometimes be thousands of lines of incredibly verbose terminal output. By simply modifying the shell commands your agent is allowed to issue, literally forcing it to truncate verbose logs with flags like this, you are acting as a strict bouncer for the context window. You do not let 5,000 lines of traceback errors into the VIP section. You're ensuring that only the absolute most critical, abbreviated structural information is allowed to cross the threshold into the container. So the whole point here is the massive contrast between chaos and control. On one side, we have raw tool output. That's the catastrophic mess of injecting thousands of lines of raw API logs, massive JSON dumps, or successful build traces directly into the LLM's brain. It is a guaranteed path to cognitive collapse. But on the other side, we have programmatic filtering. Advanced systems teach the agent that when it wants to analyze a massive data set, it shouldn't try to read it directly. Instead, the agent writes a quick Python orchestration script, maybe using pandas, and executes it inside a local, isolated, secure sandbox. That script handles the massive 50,000-row data load, runs the loops, crunches the numbers, and filters the noise locally. It then returns exactly one thing to the main agent, a highly refined, tiny structural summary, maybe just a string that says revenue up 4%. It's the ultimate defense against context decay. As we wrap up this explainer, I want you to look at your own engineering workflows. Slow down for a second and ask yourself this provocative question. Your agent's brain is a finite container.
What kind of clutter are you forcing it to hold? Seriously, stop letting your highly capable autonomous agents drown in unstructured, useless noise. Implement those partition walls, anchor your foundation stones at the root, build your sliding drawers for progressive disclosure, and rigorously filter your outputs. Take control of the physical space of your data today, and you'll watch your CLI agents perform at a level of brilliance you probably never thought possible.